Hello and welcome back to the channel. So this lecture we are going to discuss about how we can build a reliable data lakes storage solution for your Apache Spark. So without further ado, let's get into it. Last few lectures was all about the streaming API of Apache Spark, where we have seen how we can process the data coming in real time. But we haven't discovered how we can integrate Spark streaming with Kafka as a source or the sink. But let's leave that aside. We can talk about it later in a separate video, because now we are going to focus one of the most important topic for every Apache Spark developer in the world, which is like building a reliable data lake with Apache Spark. Because everyone can code, everyone can build the logic if he knows the basics, but building a reliable and scalable data lakes is very important. So we are going to go over some of the basic concept of storage solutions that we need to look out for building a reliable data lake. So without wasting any time, let's jump into it. So we already learned that how we can easily and effectively use Spark for building scalable as well as performant data processing pipelines. So we have also looked out some examples where we are processing data either in the batch mode or the real time. But in practice, expressing the processing logic will only solve the half of the problem. And for all the data engineers, data scientists or the data analysts, the ultimate goal will be to build the pipeline which to query the processed data and get the insight out of it. Because at the end of the day, getting the insights from the data is our main target. And also the choices of storage solution will determine the end-to-end robustness of the data pipeline. So storage solution, you have to make sure that you are choosing a correct and the most appropriate storage solution for your application. That we are going to see in this lecture. First, we will discuss about some of the importance of optimal storage solution. So these are like some of the points which is very important and required for optimal storage solution. The first being the scalability as well as the performance. So the storage solution should be able to scale to the volume of data, and it should provide the read and write throughput and the latency that the particular workload requires. So as per your application, your storage solution should scale horizontally as well as it should perform to withstand the huge amount of data you are bringing into the system. The next one is like the transactional support. It is very important for maintaining the accuracy of your transactions. So the complete workloads are often reading and writing data concurrently. So the support of these ACID transactions, I hope you know about the ACID. If not, we have already discussed it in our previous lectures. So this ACID transaction is essentially for ensuring the quality of the end result. And I can say accuracy over quality in this case. Then also the next one is like the support for diverse data format, because in this day and age there are different data formats are out there. Some of them are good for some application and some of them will be bad for some applications. So you have to very carefully choose the data formats here. So our storage solution should be able to store unstructured data as well as it should store the semi-structured data and the structured data. So all kinds of data it should handle. Then also it should have the support for diverse workload. So what it means is it should able to support diverse range of business workloads, and it could include different things like SQL workloads for BI analytics, batch workloads like the traditional ETL jobs, as well as the streaming workloads for real-time monitoring and alerting, as well as the ML and AI workloads for recommendation and the prediction models. So this is very required. And the last one is like openness. It is not about you, it is about Apache Kafka. So supporting a wide range of workloads will often require the data to be stored in the open data formats. So the standard API will allow data to be accessed from variety of tools and engines. And this will allow business to use most optimal tool for each type of workload and make the best business decision. Because choosing the right tool is also a very important step for every storage solution in the business. So these were like some of the points you need to ensure to deploy an optimal storage solution. And over the time, different kind of storage solution are proposed, each with unique advantages as well as the disadvantages. So now we are going to explore how the available storage solution evolved from databases to the data lakes and how to use Apache Spark with each of them. So first, let's talk about the databases. So for many decades, databases have been most reliable solution for building data warehouses, and it stores the business critical data. So now we will explore the architecture of databases and their workloads and how we can use Apache Spark for analytic workloads on these databases. And also we will discuss some of the limitations as well. So let's talk about a brief introduction to the database. So what is a database actually? So databases are like designed for storing structured data as tables. So tables consist of different rows and columns, and it is similar to what a table in a relational database. It has certain amount of columns and the rows and have the specific rules assigned to that. And we can use the SQL query for reading the data from that table. So data must be adhered to strict schema, which allows the database for management system to heavily co-optimize the data storage as well as the processing. So those are the rules I was talking about. So these workloads are broadly classified into two major categories. The first one is a OLTP, which is online transactional processing, as well as the OLAP, which is online analytical processing. So the first one, which is OLTP workloads. So like the bank account transaction, OLTP workloads are typically very high concurrency, it has the lowest latency, and it is made for simple queries which will read or update the few records at a time. So it is not used for heavy analytics purpose. If you want to get some insight out of your data by applying complex joins or some complex queries, there comes the OLAP, which is online analytical processing. So as the name suggests, it is totally suitable for submitting complex SQL queries on top of your tables. And also it is important to know that Apache Spark is a query engine, which is like primarily designed for the OLAP workloads. Whatever you are doing in Apache Spark is like a data processing, and you are supposed to run complex operation on top of your data. So that's why OLAP will make much more sense in case of Apache Spark. So you may ask how we can read and write to the databases using Apache Spark. So we have to thank for ever-growing ecosystem of the connectors. Apache Spark will connect to wide variety of databases. So it can read and write through the JDBC drivers, and we can connect to any databases like PostgreSQL, MySQL, and also we can use like the built-in JDBC data source along with the appropriate jar files for accessing that data. And for many other databases like Azure Cosmos DB as well as the Snowflakes, which are like the cloud option out there, there are the dedicated connectors we can invoke using the appropriate format name. So this format name is very important while reading as well as writing the data, and we can use the read or write method and pass that particular data source as an argument. So this makes very easy to augment your data warehouse as well as database with workloads and use case based on the Apache Spark. So that's why databases are pretty versatile solution in the previous decades. But there are some limitations to these databases, and that's why data lakes take over the databases, and they are very popular nowadays. So let's talk about the limitations now. So since last century, databases and SQL queries have been known as a great building solutions for BI workloads. But there are some major drawbacks of using databases, like growth in the data sizes. Because in the today's era, the data is growing at a rapid rate. Companies, apps, or many online platforms are generating petabytes of data. So this day and age, there has been a global trend in the industry to measure and collect everything. So everything out there is data. Either it could be structured, semi-structured, and majority of them is unstructured. And companies are tilted towards getting meaning out of all this data. So that's why growth in the data sizes is a pretty big limitation for the databases, because they are not meant to grow in this kind of rapid rate. The next one is like growth in diversity of analytics. What it means is like along with the increase of data collection or the data generation, there is like need for deeper insights. So this has led to explosive growth of complex analytics like machine learning and the deep learning. So that's why databases have this biggest limitation out there, because it doesn't provide that growth in this diverse of analytics, and it has like inadequate at accommodating these new trends. The next one is like they are very extremely expensive for scaling out. So although databases are extremely efficient at processing data on a single machine, the rate of growth of data volumes has outpaced the growth in the performance capabilities on a single machine. You cannot rely on single machine. If a company is generating gigabytes and petabytes of data, single machine is not even close to process that data. So the only way forward for processing engines is to scale out. That is like use multiple machines to process data in parallel. But however, most databases, especially like the open source ones, are not designed to work that way. So the few industry database solution can remotely keep up with the processing requirements. They tend to be very pricier solution, and it requires a specialized hardware as well, and therefore they are very expensive to scale out. And it also does not support like non-SQL based analytics. So databases store data in complex formats that are typically highly optimized for only that database's SQL processing. So this means that other processing tools like machine learning and deep learning system cannot efficiently access the data, right? So nor can databases be easily extended to perform non-SQL based analytics like machine learning. So that's why databases have taken a back foot because of these major limitations. And this is why there is a next player in the game right now, which is again very popular after the databases, which is data lake. So now we will see all about the data lakes. Okay, so the next one is data lake. So in contrast to most databases out there, a data lake is just like a distributed storage solution which will run on a commodity hardware. So commodity hardware means it is easily replaceable, cheap hardware which will be very cost effective, and we can just scale it out horizontally. Horizontally means we can add as much of these commodity hardwares and they will work in parallel and do your job. So we will first start discussing how data lakes satisfy the requirement of modern workloads, and then we will also see how Apache Spark will integrate with these data lakes to make the workloads to scale of any size. So it is very beneficial for companies out there which are generating gigabytes and petabytes of data every day, because it will help them scale horizontally in a very cost effective manner. So let's take a brief introduction to data lakes. So a data lake architecture, which is like opposite to the databases, which decouples the distributed storage system from the distributed compute system. So this will allow each system to scale out as needed by your workload or the application. So furthermore, this data is saved as files with the open formats. So such as like processing engines can read and write data using the standard APIs. So this idea is very popularized in the late 2000s by the HDFS, which is like Hadoop distributed file system, which came from the Apache Hadoop project, which itself heavily inspired and based on the Google file system, and everyone knows about it. So for organization to build their data lakes, they have to choose the following components. The first one being the storage size, which is very important, right? So they will choose either to run HDFS on the cluster of machines, or they can use like Cloud Object Store, which is like AWS S3, Azure Data Lake Storage, or Google Cloud Storage, which is provided by GCP. Then next one will be the file format. So there are different file formats out there, and it is totally depends on the downstream workloads you have in your system. So the data is stored on file either in the structured format like Parquet, ORC, as well as the semi-structured like JSON, or sometimes even unstructured format like text, images, audio, video, etc. Then also you have to choose the processing engine here. So again, depending on the kinds of analytic workloads you have to perform on your system, a processing engine is chosen. So this can be the batch processing engine like Apache Spark. We have also the Apache Hive, Presto, as well as the stream processing engine like again Apache Spark, Apache Flink, as well as the machine learning library. There also comes the Apache Spark, which provides MLlib as well as scikit-learn and R. So this flexibility to choose the storage system as well as the open data format as well as the processing engine will be best suited for any workload out there, and it is like the biggest advantage of data lakes over the database. And on the whole, for the same performance characteristic, data lakes often provides a much cheaper solution than the databases because we are using commodity hardwares in parallel manner. So these key advantages has led to the explosive growth of big data ecosystem. So let's discuss how we can read and write data to data lake using the Apache Spark. So Spark is one of the best processing engine out there because of its in-memory computation and direct acyclic graph, and it can use when building your own data lake because it provides all the key features they require. It will require you the support for diverse workloads, so it will provide all the necessary tools to handle a diverse range of workloads, which includes like SQL workloads, ETL workloads, stream processing, as well as MLlib. So you don't have to worry about choosing the different solution for different purposes. We can use one and that's it. Then it has like diverse file formats. So we have explored it very in depth in our previous lectures. What are the different type formats Spark will provide and what are the benefits and the cons. Also it has diverse file system as well. So it supports accessing data from any storage system like HADOOP file system, HDFS for example. And also it could integrate with the cloud or on-premise storage solutions. But however, many file system you have to configure Spark such that it can access the file system in a secure manner, because if you are handling like a sensitive data, this could go wrong. And also cloud storage system often do not have the same file operation semantics expected for the standard file system. So you have to also make a big effort to integrate that. And it also has some limitations as well because nothing is perfect, right? So data lakes are not without their shape of flaws, right? So the most egregious of which is lack of transactional guarantees. Especially these data lakes will fail to provide ACID guarantees on the atomicity and the isolation as well as the consistency. So for atomicity and isolation, this processing engine will write the data in data lakes as many files in the distributed manner. But if the operation fails, there is no mechanism to roll back the files which are already written, right? So this is very big flaw. So thus it will be leaving behind potentially corrupted data. And also if you talk about consistency, the lack of atomicity on the failed writes will further cause readers to get the inconsistent view of the data. So it could hamper the end results and insight from your data. And it is very common issue with the data lake which accidentally writes out data files in format and schema which is very inconsistent with the existing schema. So to work around this limitation of data lakes, developers employ all sort of tricks, like large collection of data files are often partitioned, which is like chunks of data, and they partition it by subdirectories based on the column value. So example, like a large Parquet formatted Hive table which is partitioned by the date. So to archive atomic modification of existing data, often these entire subdirectories are rewritten just to update or delete few records. This is like some of the tricks that developers came around to handle these limitations, as well as the schedule of data update jobs and the data querying jobs are often staggered to avoid concurrent access to the data and any inconsistency caused due to it. But there is another big solution which overcomes some of the limitations of data lake, which is like lake house, which is like a next step in evolution of storage solution. So that we are going to see in depth in the next lecture. So I hope you got a clear understanding of what a database is, what are data lakes, how Spark can use it for reading and writing the data either from the data lake or database, and which is more preferable in today's era. But lake houses will make a much more difference, and that we are going to see in the next lecture. I hope you like this lecture, so please subscribe to our channel and also ring the notification bell to get the latest updates. And don't forget to follow us on our social media, which is linked in the description below. Thanks for watching.